Welcome to Pre-Calculus Trig, Part 2 of Section 2.4 on solving trig equations. We're going to get into a few more types of example problems. So with this example, we're asked to solve the sine of x is equal to negative 0.38 on the interval 0 to 2 pi. So the first thing we're going to notice is that this negative 0.38 values is not one of our sine values for the special triangles on the unit circle. So we have to use a different technique. So we're going to take the inverse sine of both sides. So let's do that first. So basically, this is something that we were doing without writing it down before. When you take the inverse sine of the sine of x, that undoes the sine and just gives you x. So that's your angle x. So that's the left side. So now the inverse sine of negative 0.38. And we have to type that into the calculator. So you're going to be in mode radians in your calculator. And you're going to type in inverse sine of negative 0.38. And you should get in radians that your angle x is equal to negative 0.3898 radians. So let's take a look at the circle. All right, so from 0 to 2 pi. Now, if you have a angle x is equal to negative 0.3898 radians, what you have to remember is that when you take the inverse sine of an angle, it's going to return you an angle in the interval negative pi over 2 to pi over 2. Okay, because that's the range of our angles that you can get out of an inverse sine function. So if we look at the x is equal to negative 0.3898 radians amount, that's going to put us down here where this is your negative direction. So right here I've got negative 0.3898 radians. Okay, so when we're talking about sine, what we have to realize is that that's only one of the angles that we have. We've also got that same sine value in the third quadrant. All right, so sine value is that dimension from here to here, your y dimension. So there's also another angle with the equivalent sine in the third quadrant. So your inverse sine function is only going to give you the one angle, which is between negative pi over 2 and pi over 2. And you have to realize that there's another one. There's another angle that's going to be a solution to this problem. All right, so now what we're going to notice is that this amount of rotation from here to here is the equivalent. So these two are equivalent amounts of rotation. So we can use that to figure out what the positive values for our angles are, which is what we want to report. So if I'm going from my initial side of 0 to this side here, that's going to be one of my angles. And I'm going to have a second one going from my initial side to my terminal side here, rotating in the positive direction for both of these. Those are going to be my two angles, which are my solutions. All right, so let's go ahead and find the red one first. So for the red one, if I'm going from 0 to this line over here, that means it's pi radians to here, and then I'm going to add on that 0.3898 amount to pi. So my red one is going to be the angle x is equal to pi plus an additional 0.3898 radians. All right, so that's going to give me an amount equal to 3.5314 radians. All right, so that's one of my angles. All right, and if I look back up at my original problem statement, I'm asked to solve this equation on the interval 0 to 2 pi. So if I put a decimal value for 2 pi in there, we can check against that to make sure that I'm not outside that range. So 3.5314 is within this range here. All right, so that takes care of the red one. Now let's look at the pink one. So the pink one, if I'm looking at my picture, my positive angle is going to go all the way around to 2 pi, and then I could take off this 0.3898 amount, and I'll be on this terminal side here. So we can calculate that angle by saying 2 pi minus 0.3898 radians. So if you run that through your calculator, you should get 5.8934 radians. Right? And that is also less than 2 pi, which is 6.28 radians. All right, so we found that there are two solutions for this equation between 0 and 2 pi. So this is a similar type of a problem. We're asked to solve a cosine equation where the cosine of the angle x is equal to positive 0.72. So we want all solutions on the interval 0 to 2 pi. So if we take the inverse cosine of both sides, we're going to get the angle x is equal to the inverse cosine of 0.72. If I type that into the calculator, I'm going to get it in radians. Remember, you're going to put your mode in radians here. We're going to get your angle x is equal to 0.76699 radians. All right, so then if I look at my circle, the first thing I want to remember is that the inverse cosine function returns an angle between 0 and pi, which means it's only given you one of your angles. You have to figure out what the other one is. So sometimes I find it helpful just to write your decimal equivalents on here for pi over 2 and pi and 3 pi over 2. And then, of course, this would be 2 pi, just so that you get a feel for the numbers that you're getting out for the angles. So if I've got an angle x is equal to 0.76699 radians, that's in quadrant 1. So let's just draw this angle here. So this is your 0.76699 angle from here to here in radians. So that angle has a positive cosine. So cosine being your x dimension from here to here. But as we know, there's also another angle in the fourth quadrant that's going to have that same cosine value. All right, so we got to figure out what that angle is in radians as well. All right, so let's do it in a different color here. So if I want a positive angle, I start at 0 and I rotate around to here. All right, so I've got this angle here is 0.7, that's this number here, 0.76699 radians. Now I want to figure out what this angle is here. Okay, you see the symmetry of the problem. If this part here, this angle is 0.76699, this also would be 0.76699 here. So I could figure out the second angle by saying x is equal to 2 pi, that's one full revolution, minus that piece that is 0.76699 radians. So if I run that through the calculator, I'm going to get that my angle x there is 5.5162 radians. That's this line over here, 5.5162 radians. Okay, so we found both of the angles that have a cosine, which is this dimension here, equal to this 0.72 number by using our inverse cosine feature. So in this problem, we're asked to solve the sine of the angle theta divided by 2 plus pi over 2, so this is an angle with a period change and a phase shift, is equal to negative 1/2 on the interval 0 to 2 pi. Okay, so we know that negative 1/2 is one of our standard sine values. So if we draw our circle, we know that the sine is negative 1/2 in the fourth quadrant and the third quadrant, where these two angles would be 7 pi over 6 and 11 pi over 6, which you can verify in your unit circle. Okay, so we know that those angles exist there between 0 and 2 pi. Now we want to see what happens if we apply that period change and the phase shift to those two angles. So we can say that the angle theta over 2 plus pi over 2, that translated angle, has got to equal 7 pi over 6 in order to have that sine value, a negative 1/2. So let's work on this one first. So I'm trying to get that theta here. I'm solving for theta. That's the variable in my problem. And I'm just going to do some algebra here. I'm going to subtract pi over 2 from both sides. So that means theta over 2 is equal to 7 pi over 6 minus pi over 2. So I need a sixth in the bottom here. So that's 7 pi over 6 minus 3 pi over 6 is 4 pi over 6. And that reduces to 2 pi over 3. So I have theta over 2 is equal to 2 pi over 3. So I'm looking for theta, remember, so I need to multiply both sides by 2. So that gives me theta is equal to 4 pi over 3. All right, so if theta is 4 pi over 3, then I have a true equation. So the significance of that is if I put 4 pi over 3 in for theta, divide that by 2 and add pi over 2 and take the sine of that, I should get negative 1/2. So 4 pi over 3 is definitely less than 2 pi. It's between 0 and 2 pi, because 4/3 is 1 1/3. Okay, so that one works. All right, so now we're going to do the other angle. So we're going to work on the 11 pi over 6 angle now. So we're going to say, let's go back to the top a minute, theta over 2 plus pi over 2. This time it's equal to 11 pi over 6. So I'm going to say theta over 2 is equal to 11 pi over 6 minus pi over 2. So I need sixths. So I get 11 sixths minus 3 sixths. So that's 8 sixths, which can reduce to 4/3. All right, so that's theta over 2. So now I have to multiply both sides by 2. So that's theta is equal to 8 pi over 3. 3. All right, so now let's check to see if that's less than 2 pi. So it would have to be between 0 and 2 pi. 2 pi in terms of thirds is 6 pi over 3. Okay, so that's outside of where I want to be. So this is going to be a no right here. It's too big. It's outside of the given range of answers, 0 to 2 pi. So I only have one solution to this problem. Theta is equal to 4 pi over 3. So in example 9, we're told that the cosine of 2 theta minus pi over 4 is equal to 1. And we want to find the thetas on the interval 0 to 2 pi. This should usually be a smooth bracket. All right, so if I look at my circle, I want to find angles where the cosine is equal to 1. So that puts me over here at 0. So right here, my cosine is equal to 1. So that means that my angle, this is my transformed angle, 2 theta minus pi over 4, has got to be equal to the angle 0 in order to get that cosine equal to 1. So I have to solve for that theta there that's going to make this statement a true statement. So I add that pi over 4 to the other side, and then I divide by 2. So that's theta is equal to pi over 8 radians. Okay, so that is definitely between 0 and 2 pi. So when theta is equal to pi over 8, I have a true statement. So we have one solution to this equation. So this example says solve 3 cosine of 4x is equal to 1 for the 2 smallest positive solutions. So I'm going to isolate my trig function by dividing by 3. So the cosine of 4x is equal to 1/3. So 1/3 is not the cosine of any of my standard angles on the unit circle. So we have to undo this using the inverse cosine. So I'll write it all out. Take the inverse cosine of both sides, and you'll get 4x is equal to, typing that into the calculator in radians, you're going to get 1.23096 radians. All right, so it's telling me an angle of that size has a cosine of 1/3. So let's draw that on the circle. So we know that if we take an inverse cosine, the angle it gives you back will be the angle in that range here in pink. So 1.23096 radians is in that angle range there. So I wrote my decimal equivalents for radians around my circle here, so we can see these numbers here, so we can see where we are. So if I'm at 1.23096 radians, then I would be in the first quadrant here. Okay, and my cosine is 1/3. All right, so that means we're talking about my cosine here being 1/3. But we know there's going to be another angle down here that has the same cosine. All right, so if this one here is 1.23096, we want to also figure out what this one here is as well. All right, so what we can see from the symmetry here is it's 1.23096 in the positive direction to hit this terminal side, and it's 1.23096 in the negative direction to hit this terminal side. So I can take one full revolution, 2 pi, and subtract off 1.23096, and that'll give me that green angle. So that means my angle 4x is equal to 2 pi minus 1.23096. So that's, if you type it into your calculator, you should get 5.05223 radians. So that's this one here, 5.05223 radians. Okay, so there's one more step. We have to divide by that 4 there. So we have two angles for x. We have the 1.23096 angle, let's just say comma, and we have the 5.05223 angle. So we just want x, so we're going to have to divide these angles by 4 to get our solution, the angle x. So if you type that into the calculator, you're going to get 0.30774 radians and 1.2631 radians. Those are going to be my two smallest solutions. Of course, there are other ones, and the reason I know that is because of this period change here. There's going to be more, but it only asked for the two smallest ones. So we're done at that point. So when you have this period change here, and they've got a multiplier of 4 there, you're really going to have 4 times 2, which is 8 solutions. But we're not asked for all of the solutions. We're only asked for the smallest 2. So that would be these two right here. So here we're solving the secant of 2x is equal to negative root 2. On the interval 0 to 2 pi. So the first thing you do is you write your secant is 1 over the cosine of 2x. So that's equal to negative root 2 over 1. So if I take the reciprocal of both sides, I'll have the cosine of 2x is equal to negative 1 over root 2. And if I rationalize the denominator, I'll see that I'll get negative root 2 over 2, which is one of our values of cosine for our 45-degree angles on the unit circle. So next, I draw a sketch of the unit circle, and the places where the cosine is negative root 2 over 2 are going to be in the second quadrant at the 45-degree line, 3 pi over 4, and then in the third quadrant at 5 pi over 4. All right, so that tells me that my angle is equal to, my angle 2x is equal to 3 pi over 4. So let's do it in different colors. And my angle 2x is also going to equal 5 pi over 4. Okay, since I have a period change with that 2 here in front of the x, that means instead of my standard period 2 pi over b, where b is 1, so my standard period for the secant is 2 pi, I've got 2 pi over 2, which is pi. So what that tells me, it's going to take 2 entire trips around the unit circle to go this far. So I'm going to, let's do, and one trip I'll hit here, and that'll be a solution, and here, and that'll be a solution. But I've technically only gone half of my my allotment, if you will. So I can go another trip around here and hit it here again, and here again, and so that'll give me 4 solutions to this problem. 2 coterminal angles here and 2 coterminal angles here, because I can make 2 full trips around the unit circle before I hit 2 pi, since my period is only half. So I'm going to have 4 solutions to this problem here. So I need to find the other 2 angles here, so that'll be 3 pi over 4 plus 2 pi, so that'll be a coterminal angle, and here I'll have 5 pi over 4 plus 2 pi, so it'll be my other coterminal angle for that one. So that's going to be my 4 angles. So I'll have 2x is equal to 3 pi over 4, and so 2 pi is 8 pi over 4, so that would be 11 pi over 4 for that second angle. And then for the red ones, I'll have 5 pi over 4, and then 5 pi over 4 plus 8 pi over 4, which is 13 pi over 4. All right, so the last thing to do then is to divide by 2. So I'm going to divide by 2 for all of these angles here to get my final values for x. Right, so I'll get x is equal to 3 pi over 8, 11 pi over 8, 5 pi over 8, and 13 pi over 8. So I've got 4 angles between 0 and 2 pi that are going to have a secant equal to negative root 2. And the reason I have 4 and not just 2 is because my period is only pi. So I'm going to hit them twice and then twice again. So 4 solutions to this equation. So we're going to solve the cosecant of 5x minus 8 is equal to 0 for the 4 smallest positive solutions. So right there it's implying that there's probably more than 4. Now you might want to stop the video and think about this for a minute and see if any of this is sinking in. If I have a 5 in front of here, in front of my x, my normal period for a cosecant function is 2 pi. All right, and I've got a 5 here, so my period is going to be 2 pi divided by 5. How many solutions do you think I'm going to have between 0 and 2 pi? So just stop the video and think about that for a second. So if you said 10, you're correct. There are 10 solutions to this equation because I have this multiplier here in front of the angle x. So that says if I normally have 2 solutions for the cosecant, I'm going to multiply it by 5. All right, but I only want 4. So let's go ahead and write this in terms of the sign so we can understand what's going on. So this is 1 over the sine of 5x. And then move the 8 over to the other side. So this is 8 over 1. So if I flip both of these fractions, take the reciprocal in other words, I'll get the sine of 5x is equal to 1/8. All right, so that's not one of the signs of our special angles. So we're going to take the inverse sine of both sides to get the angle 5x. And you plug that into your calculator. The inverse sine of 1/8 is in radians, mode radians, 12533 radians. So let's look at our circle. So since we took an inverse sine, that means, remember the one-to-one thing, it's going to return you one value for the angle, and it's going to be between negative pi over 2 and pi over 2. So your angle that it returns you is going to be on this side of the circle. So if pi over 2 is 1.57 radians, then that means 0.12533 radians is going to be somewhere lower, about right there maybe. So let's write that on there. This is 0.12533 radians. Right, so that's this angle here. Right, since we're talking about sine, we know that there's going to be another angle that's going to have that same sign over here in the second quadrant. All right, and that's going to be this angle here. So we also know that this amount right here, due to the symmetry of this problem, is the same as this angle over here, 0.12533 radians. So if I'm going from 0 to here, I'm going to figure that angle out by saying I've got pi radians minus this piece here. All right, so I've also got 5x is equal to pi minus 0.12533 radians. And if you type that into the calculator, you should get 3.0163 radians. So that's this angle here, 3.0163 radians. All right. So we're asked for the 4 smallest positive solutions, and we know there are 10, so we're not going to figure out all 10 of them. So we're going to get the 4 smallest by taking the first 2 for each of those angles. Okay? So let's take a look at 5x is equal to point. Let's do it in red. So starting with the red angle, the next angle in line would be coterminal to that one, the next smallest. So I'm going to add 2 pi to figure out that one. All right, so let me just leave that there for a second. Let's do the green one as well. I'm going to have 5x is equal to this angle, 3.0163. And the next largest would be 3.0163 plus the coterminal angle that comes next, add 2 pi. All right, so we've got, let's just work on these equations here. We've got 5x is equal to 0.12533, and then if I add that up there, I get 6.40851. And then over here, I've got 3.0163, and adding those 2 numbers up, I'm going to get 9.2994 radians. Okay, so the last thing to do is to divide by 5. So I'm going to divide by 5 because I just want to find out what x is. And these will be my 4 smallest angles. So there's really a list of 5 coterminal angles here and 5 coterminal angles here, but we're only doing the 2 smallest here and the 2 smallest here, which would give us our overall 4 smallest angles. So that means x is equal to 0. Let's see what it's equal to, 0.2507, and also 1.2817. And then for these over here, I'm getting 2 angles, 0.6033 and 1.85989. Okay, so those are going to be my 4 smallest angles. All right, and those are all within the range that we were asked to use. Well, we weren't given a range, we were just asked for the 4 smallest. So these are the 4 smallest. So that takes care of all the examples for 2.4. Hope you took good notes and you're ready to work the problems. Go ahead and let me know if you have any questions.